In section 3 of Unit 1 for Honors Math 2, it's going to be on the probably the most fun type of factoring that there is in my mind. In my mind, I like this because it's like a puzzle. Like, some people will be able to look at this and boom, know what the answer is. Some of you are going to have to try several different things. Some of you are not going to like it because there's not a straightforward do this and then your steps will come out right. It's the method that I'm going to use is called the guess and check method. And a lot of students, it's kind of like 60-40, who likes it and who doesn't like it, I should say. But let's show you how it works so that you guys can see the most popular kind of factoring that you'll have to do in higher level mathematics. The guess and check method is where we break the trinomial up into the product of two binomials. So if you have a 3-object polynomial, y squared plus 5y plus 6, 1, 2, 3. This is a trinomial. We want to break it up into two binomials that are multiplying. We're going to turn this from addition into multiplication. That's what factoring really is. We're going to do this. We're going to break the trinomial's first term into two terms. That's split to be the front. We're going to break the trinomial's last term, and then we're going to check by combining the O and the I. Here's how it works. I picked number 1 for you. What I'm going to do is take this first term of whatever it is, and I'm going to split it apart. Since it has to be a 5y in the middle, I'm pretty sure that the only way I can get to y squared is a y times a y. I write that usually right below it. I break it up into two things that can multiply to be y squared. And then what we do is we're going to split that into the front of each parentheses, meaning this thing here and this thing here are going to be based off of what those two things are. The second thing we do is break the trinomial's last term into two terms. This is where it gets slightly more complicated, because how can we multiply to be 6? There's a couple different options. You could have 1 times 6. You could have 2 times 3. You could have 3 times 2. Or you could have 6 times 1. There's 4 different ways we could do this. And this is where some of you are going to either like it or not like it. You have to figure out which ones are right, which ones work. And the only way, because we're going to guess, and then we're going to check. The only way we're going to know if our guess is correct is by checking. How do we check? We check by combining the products of the outside, the O, and the products of the inside, the I, in FOIL. The O and I in FOIL. So here's what I do. I'm going to pick 1 and 6, and I want to show you how this looks. If I were to do 1 and 6, the only way I can check is by looking at the O and the I in FOIL. This O would be y times 6, which is 6y. And the I would be 1 times y, which is 1y. Can I get to, does that add up to be 5y? If we subtracted, maybe that might work. If I had a negative. And then if I did that, and that was a negative and this was a positive, would this multiply to be a positive 6? If it doesn't, then you can't use it. Then it's something else. Okay? So if I put a negative here, it would work for this piece, but not this piece. So then what do? You go, oh, it's not going to work. You erase it. And you try different numbers. Remember how we had the 1 and 6? We try 2 and 3 next. This outside multiplies to be 3y. This inside multiplies to be 2y. Is there a way to get to 5y from there? If this was a positive and this is a positive, does the outside plus the inside equal this middle term right here in the middle? Let me underline this in green. And that's how we check. We check by adding the product of the outside plus the product of the inside. If it works, FOIL it out. Y times y, y squared. Y times that's 3y, and another 2y, make 5y, and 2 times 3 is 6. This is the correct factored form of the answer. If you were wondering, and you said y plus 2 times y plus 3, what if I got y plus 3 times y plus 2? Is that the same answer? It is, because you can write multiplication in any order that works, as long as the whole parentheses, the same things are inside. Okay? So that's how this is going to work. And so I have several examples for you to try. We will do a couple more together. Let's see. 2k squared. I'm going to break that one up. I chose number 3. 2k squared and 2k. I split it up into 2k and k because this middle term needs to be a k. So I kind of know that the only way to get to a k is by having a k in front and a k in front. Split up, if you will. The back term, on the other hand, is this plus 15. Several different options. 1 and 15, 3 and 5, 5, 3, and 15 and 1. Sometimes putting the 1 here and the 15 there may not work, but putting the 15 here and the 1 here may work. What are we trying to get? We're trying to get to the 13. If I put the 1 here and the 15 here, look at what the outside would be. 30 and 1. Does that make 13? Then let's not use those two numbers. Or let's not use those numbers in that spot. What if I use the 15 here and the 1 there? Let's see. I have 15k and 2k. 15k, 2k. Ooh, that might work if I subtract the 2k. Let's see. If I subtract the 2k, that would make this negative and this one positive. Now let's check it. Yes, 2k squared, negative 2k, and positive 15k makes 13k. But does the last times the last equal a positive 15? It doesn't. So that must mean we have to use different factors. That must mean that the negative 1 and the positive 15 don't work. So I use something different. Whoa. So let's see. How about 3 and 5? If I go 5 here, 3 there, 5. Whoa. 5, 3. That would make 10k and 3k. Does that make 13? And does that multiply here where the last times the last still equals that last number, the positive 15? If so, you have found your answer. Make sure you double check by foiling it all out. 2k squared, yes, 10k, and another 3k make 13k. And then you will get really good at this. You may even be able to do this in your head. I do recommend that you start with the side that is prime. What does that mean? That means that if you know that, 40 is 4 times 10, 2 times 20, 8 times 5, or a 3p and a p, you know that the first side is going to be a 3p and a p. It has to be. And what I literally will be doing when I do these problems is I put like that there. That there. I usually will list out three doesn't work, 4 times 10, 5 times 8. I'll go like about there. And then what I start to do is I start playing around with what's going to multiply to be 40 but add to be negative 7. So I start thinking in my head, okay, that'd be 10p and 12p. 10p and 12p. That's 22 or 2. That doesn't work. What if I were to do 30 and 4? That doesn't work. What if I were to do 8p and 15p? 8p, 15p. 15 minus 8 is 7. That might work. I'm going to try the 5 and the 8. And I'm trying to walk you through how I narrow it down a little bit. So I'm going to try 5 and 8. I want 15p. How do I get 15p? I do 3 times 5 is 15. 8 times p is 8. So I want 15 and 8. Here's 15p. Here's 8p. I think I can get to a negative 7p if I were to do 8p positively, put a plus sign right there in front of the 8. And if I were to do 15 as a negative and put a negative sign in front of the 5. Now let's check that. 3p squared minus 15p plus 8p, does that make negative 7p? Does a positive 8 times a negative 5 equal negative 40? If so, we found the correct factorization. We've checked it. We know it is right. If it doesn't check, it means use the different factors. Use different factors. Okay? Number 8. Well, I know this one's prime, 3d and d. I know 3d times d is 3d squared. 12, I have a couple different options. 12 times 1, 2 times 6, 3 times 4, or the other way. But we need to get to this positive 20. So in your mind, when you're doing this, multiply them and go, okay, that would make 9, and that would make 4. I need it bigger. I need bigger numbers. Okay, that would make 18, and that would make 2. 18 and 2, that makes 20. So what if I got the 3d times a 6 and the d times a 2? Your mind is a powerful weapon. Let's use it. 3d times 6, I want that to be a positive 18d, so I'm going to put a plus sign in front of the 6. I'm going to put a plus sign in front of the 2 so that it adds to be this middle term. Every single time, the only real way we're going to check when we FOIL it is we're looking to see, does it add to be that middle term? Then we FOIL it, 3d squared, 18, 19, 20, plus 12. It works! If what I'm doing is hard, it's just because you haven't done it enough yet. Last example. Number 12. 4x squared minus 36x plus 81. Okay, this one's a little bit tougher because we have a 4x times a 1x. We have a 2x times a 2x. We have two different things that it could be over here. And over here it could be 81 times 1. It could be 3 times 27. It could be 9 times 9. Or anything else in the other order. So there's got to be at least like 6 different combinations of what it could be. Maybe 12. And we got to figure out which one's going to add to negative 36. So let's just start playing around with O's and I's. Outsides. 4 times 81 and then a 1x is not going to make 36. 81 times 4, that's not going to work. 12 and 27. 12 and 27. 39 does not make 36. It was close. 4, that would be too big. 36 and 9 does not make 36. I'm going to try the 2x and the 2x. Too big. 6 and 54 doesn't work. How about 18x and 18x? So let's use the 2x and 2x, the 9 and the 9. If you're wondering where I got 18, I'm checking this number and this number, and I'm getting 18x and I'm getting 18x. But I want it to be negative 36. So what does that mean? Negative, negative. Does a negative times a negative equal a positive? If so, there is your answer. I'm going to end your notes right there.